Hi everyone, welcome to EMC2GO, and today we're going to unbox this equipment. So today I'm going to show you what we have here today, and we are going to unbox this CEMaster. Okay. So we have this nice unit. It's quite heavy. Doesn't have the plug. So we'll get the plug and then we'll power this one up. What we have here in the box bag is a ESD simulator. Yes, we have this ESD simulator as well. Hopefully this one works. We have the fiber interface, some RS-232 cable, and also have this ESD cable, which I believe this should be plugged in the front. Yeah. And this would be plugged into here. And hopefully we have the tip. Yeah, this is the contact sharp. And this is the air discharge. This is around the tip. That's perfect. It's also the contact. Yeah. So it also comes with user manual. Yeah. It's all the some notes inside. Specifications. And one thing with this doesn't come with the software, but it's not a problem. I should be able to get the software, or I can write my own software. It's not a problem. With this one, I know the KeyTek doesn't provide commands or programming commands for this one. So it took me years, maybe a couple of years to figure out, to read the communication of this device, enable me to decode the actual code of the actual command. And it's not straightforward, it's not skippy, and also it's not ASCII. It's ASCII, but it's not readable. Some are readable, but there's a checksum, which I managed to figure out the checksum in order to send the right commands. So it's not a problem. Also, I can write the command for that. Oh, that's also a good thing, is we have this fiber optic. We have this fiber optic. This is really important. So this will be at the end. Oh, so it's not exactly the right interface. It's a different plug, but it's not a problem. I can use the fiber and splice with the right interface for this one, which also goes from here to there. So at least we have this fiber optic cable. Okay, so beauty. But before we can celebrate, we have to check this one if it works. So I'll be back in a few minutes. Okay, so we'll try to power up this equipment. Okay, the top one is the EUT mains input, 10 amps, and unfortunately it's only 125 volts maximum. We are in Australia, so it is made at least 240 volts, but that's not a problem. So the best I can do with that, this is the system power, is only to use the external surge output, and I might build an external CDN, so in order to test the EUT. So I have to make sure that I won't make mistakes on plugging this one into the EUT mains input, because that says only 125 volts maximum, you see. So let's have a look. Okay, so we'll try to plug the ESD gun and power it up. Wow, beauty! So we have this on. We installed the round tip, which is the air discharge. So to start this one, just press the any key. So the first one is EFT burst, 2 is surge, 1.2 microsecond, 50 microsecond. That means it's 1.2 rise time, and 50 microsecond. The old standard specifies from 50%, sorry, 10% of the rise time to the 50% of the fall time. But the new standard requirement is 50 to 50, from 50% of rise time to 50% of the fall time. And hopefully this will still meet the 50 microsecond of pulse width. That's where the only differs. So number 3 is the power frequency. Power frequency is mainly for magnetic field. So I can connect a 1 meter loop here for testing a magnetic field. So we'll go through with that if all these functions works. So the fourth one is the ESD. Hopefully this is the one, and hopefully this one works. The number 5 is the PQF. Unfortunately, I doubt it that I can do the PQF on this machine, because the maximum input of the EUT input is only 125 volts, which is to do the PQF you need to do for Australian units, you need to run at 240 volts, and the PQF happens inside the unit. So that would be at the moment I won't be able to use the PQF. That's called Voltage Dips Interruption for 61,000-4-11. So the number 6 is the pulse magnetic. Pulse magnetic is the 61,000-4-9. That's the one that's you're applying like a surge pulse of 1.2 50 microsecond of pulse into a magnetic loop, into a single loop of magnetic. So it's some standard requires that 61,000-4-9 as well. So the 7 is the calibration, which you can only access the calibration, change the offset of the voltage if you have the right code. There's 4 codes that you need to enter with that, and I have those codes, but I won't be able to discuss it in detail. So because it comes with the unit. So the system setup as well. So the system setup is where you can do internal check all the relays are working properly. So first is we have to go with the EFT burst. So we'll see if this one works. First thing is, before I say that doing the surge, you have to power the EUT, and the maximum voltage is only 125 volts. The output here is this is where you plug the EUT and you apply the surge. But the problem is the maximum input voltage is only 125 volts, so we can't really do it. So the best option is to use a direct output from the high and low surge test. So the best thing I can do is to build a separate decoupling network. So what does decoupling network? This one has an internal decoupling network. That decoupling network prevents the surge from going back into the main supply. So, and it only allows the surge from going into the EUT. So that's what the decoupling networks is used. So that's not a problem for the decoupling network. So we can build that one. So first is we need to do the EFT. Okay, and then when you select the EFT number 1 and spray enter, you can see that the option EFT option is working. Otherwise, we won't go into this option. If the EFT card is not plugged in or is not active, it will say that this option is not available. So user defined, I can set a user defined voltage up to maximum, let's say, I know it's 2000 volts only, but I will try to 2500 volts. It works at 2500 volts. Let's see, go 4000, and it should default to the maximum. So it's only 2500 volts for the EFT. So with this one, the burst frequency is only 5 kHz, unlike the EMC, KeyTek EMC Pro Plus, which has a 100 kHz burst frequency. But that's not a problem. It's an option. The standard doesn't really requires the burst. There's some particular standard that requires 100 kHz burst frequency, but most of the standards are only 5 kHz. So we can definitely use this 5 kHz burst frequency. Means output coupling means L1. That means that where you couple the burst or the EFT burst into. So the L1 burst is, we won't be able to do that because we can't plug the EUT, or the EUT is through the EUT supply, because the maximum voltage is only 125 volts. So the only option we can do is, again, I have to build a decoupling network for EFT, and it's not that difficult. So we can try this one in 60 seconds. So first run, and you have this voltage present, and what happens is you have the high voltage burst into the one of these in the line 1, which is on line 1. For the new standard, you apply the burst on all lines L1, L2, and PE. The old standard only applies, you only required to apply between line 1 to earth, line 1 to line 2, and line 2 to earth. But at the new standards, you must apply on all the lines simultaneously. So, like for instance, you select, for this one you select L1, L2, and PE, and that applies to all lines together. But because I can't use this direct, I can't use this EUT EFT through the EUT supply, so I have to use the clamp. So the clamp is, the burst is coming out through the clamp, and this clamp is going through the decoupling network. So I apply it directly through all the lines together. So in here I can choose the clamp, which is one, and then the voltage present, and the high voltage will be present on the EFT output on the clamp, because it's running now. So to verify that we have the high voltage here, I have the oscilloscope to try, but not at the moment because I don't have this cable to this EFT attenuator network, which is converted from 1K to 50 ohms. So, and also it attenuates down to times 1000. So the next one we're going to try is the surge number 2, which is 1.250 microsecond. Let's see if this works. So I go to user defined Waveform Auto. I set an auto at 2 or 12 ohms. The internal source impedance of the surge, you can either select 2 ohms or 12 ohms. 2 ohms normally is used on when you apply between line to line, and 12 ohms is normally when you apply between line to earth. So I can either way, I can override select 2 ohms, which is from line to line, but again I can't apply directly to here. So what I can do is, in here I have to select the direct. So direct, that means the output of the surge is coming directly from this high and low output here connector. So this will be connected to one of my surge decoupling network. I might able to also use a relay or to control using a relay to an Arduino to control the relay selection between line 1 and line 2, so I can also automate that one as well. So that's not a problem. So the degree, angle degree, and again, how do you apply the phase reference is I have to use the mains input here with 110 volts AC as a reference, but that AC, that down converted mains into the EUT reference must be the same phase with the one goes to the decoupling network as well. So in order to synchronize the surge spike to the phase that you want, let's say if you want to apply 90 degrees, it must be on the top of the phase of the mains. So you have the surge going on the top, or if you go negative 1 kV, it goes downwards on the top of the sine wave. So, which is cool. So let's try to run this one, and it says no reference because we don't have an AC reference on the mains input. So I have to change the angle to random. So random 90 degrees or whatever degrees that you set is random. So you should be able to run the surge, and it's running now. And here 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so it looks working, but hopefully it works. And I'll get a differential probe to check whether we definitely have the high voltage here, and we also need to verify that our waveform is within the specs of 1.2 rise time, 1.2 microsecond rise time, and 50 microsecond from half to half as per the new standard 61000-4-5. So the next one we can try is power frequency magnetic field. We don't have the loop at the moment, but we'll see if this one has an option. It's a magnetic field option, which is a bonus. It's really a good thing. So it says user defined. It's great. It says 0.87. The first on the top is the coil factor. This is you set the coil factor. You need to know what is the coil factor of your loop. Most of the loop coil factor for the 1 meter, top of my head I can't remember, sorry, but you can work it out by using a microtesla meter and converting that microtesla into amps per meter, and then you work it out how much coil factor you need to offset, you need to add in this one in order to give the right amps per meter into the magnetic loop. So you can also set the line frequency as well, 50 Hertz, and the duration, which is 30 seconds by default. So we can try to run this one. Looks like it's running, and this is applying the constant 50 Hertz voltage current through the loop, but at the moment we don't have the loop. So hopefully, I'm assuming that this one works. So you have to exit this one and we go to the next one. And the next one is the ESD, and this is a very interesting part here. User defined 4000 kV air. So we have the air 4000 kV. So where do I apply the discharge? To my finger? No, I can't do that. I know about the high voltage, but a bit scared with the discharge. I get electric, I get a shock all the time, but yeah, that scares me. And anyway, any volunteer that I can apply ESD into the ESD high voltage? Maybe you can try. No, that's okay. Okay, I'll set it to 8,000 volts. This is what I think the maximum voltage for the air discharge. And yes, we're able to enter the 8,000 volts. We'll try 10,000 volts. If not even 1,000, sorry, not even, so 9,000, because it's only 4 digits maximum. So 8,800 is the maximum. So for the ESD, most of the ESD is only 8,000 air and 4 kV for contact. So we set it to 8 kV. So air, normal mode, and so when we try, this is 1 pulse per second. So 1 pulse per second, and we set the number of pulses, which is set it to 5. But normally we have to apply 10 discharges per polarity. So we try 10. So we'll try to run. So it says waiting. So it's waiting for me to press this button, I guess, because it's the first time I have this ESD gun. So I have to press this button. Okay, it says positive and attached to ground. So we'll try this one here. Oh, you see that? Did it test what I'm doing? I'm testing my own unit. So no worry, I won't kill this one because this is ground, and I'm discharging to the ground, and it dissipates to the ground. It has a ground connection in the back, so it's not a worry. So we'll try with negative voltage. Stop that. We'll try with negative voltage, 8,000 volts. Press run, and it still say positive, but I think it should change to negative when I press that start button. Okay, it does, and it say high voltage present, and we'll try it again. Oh, again. Ooh. Anyway, okay, so this is good. This is really good. This is really good. And for contact discharge, and before changing the tip, no, I'm just joking. Okay, just changing the tip. Just put the contact discharge here, and we'll see if. So we need to change from air to contact. It didn't change air to contact. I think we need to exit this one first and then enter user defined. Okay, now we change the contact. So the maximum of this one, we have 4 kV, so we should be fine. So we have 4 kV here. Okay, sorry, we have to press run and then press that button. So to do that contact is you have to, this one should normally you have to apply into the contact point here, then press the button. But I didn't, so I guess I have to press the one and then, okay, so do that like that. But the standard requirement is you have to hold the tip right into the contact first before we apply the high voltage, and I think it does that because you can see that the high voltage jump and then it discharges. Yeah, it does. Okay, so try with the stop that and try with the negative voltage 4 kV. Okay, and change to negative, and we have to put into the subject and then press. Okay, it works fine. Okay, so the next one is PQF. PQF, as I said, we can't really do the PKF for now because the EUT is maximum voltage is only 125 volts. So I might be able to open this one and have a look. Mostly it's the PKF card that I can take it out, and that's the most difficult part, to change the PKF to 240, because it's most of the IGBT components there is designed at 125 volts only. So removing the PKF will also allows us to use the rest of the functionality, especially this one, that we able to feed 240 volts through this EUT, provided that they have to make sure that there's no capacitor that is connected across this line here, which is rated only up to 125 volts. Otherwise, I have to change the capacitor rating in order to use this functionality in here. So the sixth one is the pulse magnetic. We'll try that. Oh, it's great. It's working fine. And pulse magnetic is, you can set the requirements like 100 amps per meter of pulse at 1.250 microsecond, and you can also set the power factor. But with the new KeyTek EMC Pro Plus and EMC Pro doesn't have this. They might have, but the card or the doesn't comes with this option. You can purchase a additional to get this option working, and this is very handy that we can connect the magnetic loop here and do the magnetic pulse magnetic. Pulse magnetic is 61000-4-9. So we'll exit that one. Okay, we'll try pulse magnetic. It's number 6. Enter, then just run and say the voltage is present, so it's working. Stop that, fix it, and the calibration number 7 is, when you enter that calibration, you need the authorization code, which that one must be entered in order to access the calibration. But this has to be done with, if you know what you're doing. But I have done this one before, so it's not a problem. So number 8 is the system setup. Parameters. You have these parameters here. All bit sounds on, and that's it. And access code. This is number 2. So here, which is you need to have the access code. We don't have the access code. So the diagnostic is you run the line diagnostic for all the relays. You can try the relays, and it says the relay failed on, AC present, interlocks on. So there's an interlocks for the AC, so we can do that. So and the rest, and well, I think it's a good, even though it's not really capable of doing the rest of the functions, especially with the search that we can do on the mains EUT input, and also the AFT, and also the PKF we can't do, but it's still good start for having this equipment in order for me to demonstrate and show you about EMC. So we'll see if we can get the differential probe and have a look at the waveform on the other video. And thanks for watching, and I hope you'll stay with us until we grow. So see you next time, and bye for now.